everyone, it's Ken here. For those of you keeping score, it's now been a full year since I found the Terminator drawings on the replica prop forum. As you know, I modified those drawings to take that static model and turn it into an animatronic model, and I built a prototype. And since then, I've been working on the parts of the hand, and I'm now up to, well, over 170 parts. In this video, we're going to move on down to the forearm and take a look at some of the more challenging parts I had to make. If you've seen the movie as many times as I have, you certainly recognize this as a Terminator forearm. Up here is where the wrist plate goes, and the hand sits above that. And the way this works, as I'm sure you know, is these cylinders and pistons go up and down to make the wrist joint and the hand above it pivot as a normal human hand would. What makes that work is that this back here is a ball joint which can pivot in any direction. Now, the wrist is supported here, and as the pistons move up and down, the wrist pivots on this ball joint. Now, you've seen me make plenty of cylinders and pistons in this series, so we're not going to get involved in that. What we are going to concentrate on is this part, which is called the cuff. This is going to require using the lathe and the fourth axis on the mill. You can see that there's quite a bit of engraving going on here, and a whole number of holes that are drilled in very specific locations. And I'd like to give a shout out to John and Kevin over at NYC CNC for helping me with the CAD on this. I know it might look straightforward to some of you, but trust me, it wasn't at all. Now, this is going to be cut out of a large block of aluminum that you'll see in a moment. So, let's head down to the workshop and start to make this part. The cuff starts out as this big beefy boy piece of aluminum here, which was about $70 worth of material. What I'm going to need to do is bore out the center portion of this out to about here. And then I'm going to need to turn down the outer side, not quite as much, and that's going to leave this portion of material, which is what we're actually going to make the cuff out of. When you remove material from the inside of a hole, whether you do it on a lathe or on the mill, the operation is known as boring. And if you watch it long enough, you'll call it boring. This operation took roughly half an hour to clear out all the material I had to remove. And as you can see, I constantly had to reach in and remove the swarf because it just keeps building up inside the hole, which is not a good thing. When you're cutting, you don't want to be recutting the same material. You can see how much swarf has built up inside the machine, and this is after I've emptied it several times. Now that I've bored out the inside of the part, it's time to profile the outside to get us down to that final dimension we need. If you're paying attention, like I wasn't, you'll see that I'm about to bozo something here. Here it comes. It's bozo time. So, I crashed the part into a dowel pin that I had forgotten to remove from the cross slide. And now with my heart in my throat, I'm checking the part to see if I've done any real damage. Fortunately, I hadn't. The ding I put into the part is going to be cut off when we move over to the mill, so I lucked out there. Now I have to realign the part in the jaws, and I had faced off the end that's sitting in the jaws, so Once it's flat against the jaws, I know that it's concentric, as you can see here. So, now we start again without the dowel pin in the way. And now you can see when the cutting starts, I'm still generating this ridiculous spaghetti swarf. I'm new to this machine, and I know a better recipe would eliminate this. I just haven't been able to figure it out yet. I'd be happy to hear anyone in the comments that can give me a good speed and feed recipe to get the chip breaker to activate. If you look closely, you can see on the chuck end of the part, I'm leaving a lip back there. And that's just to help me hold it when we move it over to the fourth axis. That lip will be parted off when the rest of the operations are complete. Before moving over to the fourth axis on the mill, which I'm going to use to do the engraving and drilling all the holes, I have to worry about that big swoop that I'm going to cut out of here. And I don't want it to go flying across the room because that would damage the end mill and possibly worse. So what I've done is I've taken a scrap piece here, which I'm going to glue inside using some cyanoacrylate or superglue. The grooves I've cut in here are to let air get in during the curing process because cyanoacrylate requires air to cure properly. Now my goal here is to twist the part as I'm inserting it inside to spread the glue around. But it's a pretty tight fit, and it's fighting me, so I give it a little bit of encouragement here. Maybe a little too much encouragement. But when I flip it over and just give it a shot, it lines up just perfectly. Next, when I mount it in the 3-jaw chuck, it's imperative that it be perfectly concentric. So I've got an indicator here to make sure that it is. Even though it's a 3-jaw chuck, if I snug the jaws and then tap the part until it is concentric, I can finally just tighten the jaws and it will stay in that position, which I've already done here. Next up is the engraving of the cuff. Now I'm doing this with a 1/64 inch end mill, and because those are so small and fragile, I'm really taking it easy on the speeds and feeds, and I'm also making 2 passes at successive depths to get the final look. Once that's complete, I begin spot drilling for all the holes that have to be drilled. And once the spot drilling is complete, I begin switching to various drill bit sizes to complete the hole pattern. The next step is to remove this big portion from the part. But because it's only held on by glue, I'm taking it nice and easy. I'm going to make 4 passes at increasing depths until I've cut all the way through. And I'm also leaving about 50 thousandths behind so that we can come back later and do a cleanup pass. Now I apply heat for a few minutes, and as soon as the glue softens, I can just pull off the waste piece. Now I run a finish pass to clean up that edge. And when that's complete, I'll make a quick trip over to the lathe and I'll part off that support piece on the chuck end. And when we're all done, after 4 hours of machining, we've gone from this big chunk of aluminum to a Terminator cuff. The next part we're going to take a look at is the ball and socket that sits here on top of this support rod, which is connected to the back of the cuff. It consists of 4 separate parts. There's the ball itself, the support that holds the ball. Hiding on the inside of that mechanism is this pin and this bushing, and they can both rotate, which gives the ball and socket the ability to move in any direction. Now we're not going to worry about making these two, they're pretty straightforward, but we will take a look at how I made the ball itself and how I made the support that holds the ball. So, let's get started. The support piece for the ball begins with a cylinder which happens to have the proper ID, so I don't have to do any work on the inside. I begin by facing it off, and then as you can see I'm using much too large of a tool to turn the profile, so we're getting all that stringy stuff. Once that's complete, I come in with a very small grooving tool to put some decorative grooves on it. And I always find it humorous that when the Terminators built themselves, they put so much time and effort into the aesthetics of parts that would simply be covered by human flesh. When that's done, we move over to the mill to remove that swoopy part to make it look really cool. And unlike the cuff, where we had to worry about a large chunk falling off, this part is small enough that I don't need any support material. I'm just going to cut it and let that small piece fall away. Finally, I spot, drill, and ream a hole to hold the pin that lets the ball pivot. And then when that's all done, it's just a quick trip back to the lathe to part it off, and this part is complete. Now it's time to make the ball that fits in the socket. I do this on the lathe using the grooving tool. Because the coolant makes this so difficult to see, I'm going to show you the cam simulation here in Fusion. It's actually an interesting process. The grooving tool begins by roughing out the shape of the ball. And then it makes a pass to clean up the grooves that are left behind. And then it makes another pass to give us that final look. Then I head over to the mill. The first thing I have to do is spot and drill a hole that's going to hold the bushing. So now I'm going to come in with an end mill to bore out the hole to the proper size to hold the bushing. The end mill isn't long enough to reach all the way through the part, so I go halfway down, turn the part 180 degrees, and come in from the other side and finish the hole. Now I rotate the part 90 degrees to cut the slot that guides the pin. Once again, the end mill isn't long enough, so I do it in 2 steps. And once that's done, I come back with an end mill to run a finishing pass to give me the final width of the groove. So the machining is finished, and now we have a ball and a socket. And offline, I made this bushing and a pin, which is just a standard dowel pin. So the way this all goes together is you just place the bushing through that hole that we bored in the ball, and then we want to line up this hole here with the hole we drilled in the socket. Get it to lock in the other side, and now you have a ball and socket that pivots. Actually, really nice. Now it's not going to pivot anywhere near this much in the actual model, just enough to give you that sense that the wrist is bending as a human wrist would. And that's it. If you like this video and would like to be notified when I release new videos in this series or in other projects, all you need to do is click subscribe. If you're interested in my other projects, you can find them at my website at www.zeman.com, or you can scan my channel here at KenTunes.
I'll be back.